Hey guys, and welcome to this turn and place tutorial. So I'm creating this or recreating because a lot of people had issues with the system. Let's get into it. So the first thing, I have this folder called turn and place, and I have these animations. All right, I'm going to delete this folder here. So the first step is to highlight all of your animations, right click, head to asset actions, edit selection and property matrix, and we need to enable root motion and force root lock on both and on all animations actually. So enable this and this. I'm going to close this off, save all. Great. Next, let's get into the animation blueprint. I'm going to right click and we're going to create a new animation blueprint. Select our skeleton and I'll just call this ABP turn in place. Now, one thing to be mindful of is every animation that came from the Lyra system already have curve modifiers built in. Right, so this is what I was using in the previous system that I did not explain early enough for everyone to understand. But later on in the series, I do show how to add your own curves to your custom animations to work with this system. Right, so the logic could work at any project. All you need to do is just follow the tutorial. Great, so I'm going to close this off and I'm going to open up my animation blueprint that I just created. So we need a few things. I'm going to start off by calling a rotate root bone node in the animation blueprint. I'm going to connect this here. Next, I want to promote the yaw to a variable, and we'll call this root yaw offset. Great. Now that we have this, what we can do is add an inertialization node so it can help with blending. And next, let's see. Well, let's create a function. Actually, let's create an enum first. I'm going to right click, create a blueprint, enum, and I'm going to call this roots bone mode. In later versions of Unreal Engine, there is already a root bone offset, but you'll need to enable plugins to access it and stuff like that. But in this case, since we're trying to make this a general tutorial, I guess, for everyone to use, I'm going to create my own custom enum. I'm going to add 3. The first one is going to be called accumulate. The second one is called blend out. And lastly, hold. Now, let's head back to our animation blueprint and we're going to create this variable. Root bone mode. And we want to select our enum for root bone mode. Great. Let's create a function. We're going to call this update root yaw offset data. Alright, we want an input of type float. Let's call this delta time. And next we're going to add a sequence. And let's get the root bone mode and check if it is equal to accumulate. Add a branch. Connect this up. Alright, now let's get our root yaw offset. And we need one more variable, so I'm just going to promote this to a variable here, and I'm going to call this actor yaw offset. Delete that, and we're going to get it, and we're going to get our root yaw offset plus the actor yaw offset multiplied by -1. So I'm going to get the inversed value and connect it here. Straighten this. Let's keep things neat and clean. Next, let's create a function called set root your offset. It's going to take in an input of type root your offset. I'm just going to add in to the beginning so we can differentiate. So in root your offset. And back in our update root your offset function, we're going to call the function set root your offset. Connect this here and connect the addition to the input. Next, on then one of our sequence, we're going to add another condition check. So let's copy this and connect then one. And now we're going to check if the root bound mode is equal to blend out. If it is, we're going to call a built-in function called floats spring interp. Let's connect this, and we need a few settings. So the current is going to be our root your offset. Now don't worry about the actor your offset, we will set that later. So I'm just going to connect this for the current. For the spring state, we can promote this to a local variable. And let's call this root your spring state. All right. For the stiffness, let's do 80. For the critical damping factor, let's do 1. The delta time is going to be our input. So I'll just copy the name, drag off here and paste, and let's get delta time. The mass is 1, and the target velocity amount, let's drop that down to 0.5. Straighten this off, and let's call our function again, set root your offset, and connect the return value to the function input. What we're checking for now, all we need to do is set. So let's set the root bone mode. So let's add a pin to our sequence and set the root bone mode to be blend out. Yeah. Great. So now let's head into our root your offset function and set it up. So it's really simple. All we need is get our root your offset, and we can promote this to a variable again. And this time, this is our last root your offset. I guess in the tutorial I called it previous, so it's like the same thing. So this is the last root your offset. And then we want to set our actual root your offset variable as the input of the function. So the in root your offset, and let's normalize the values and insert it right here. Great. This function is now complete. Now we need two really important variables, and a lot of people will face issues if this is not done correctly. So let's create one variable called turn your weight, and this is going to be of type name. Now if you open any one of the animations that I provided, you will see we have these two names. So what we're going to do is copy the name, head back to animation blueprint, compile, and paste the name in the default value. This needs to be exactly the same as in the animations, or else it would not work. It will not read the data from the curves. We will need one more variable, and let's get the name here again. So it's a remaining turn your. Let's copy it. I'm going to paste it, and let's create a bit of space here, compile, and paste in the name and the default value as well. Great. Now, a few things. We will need a way of inserting the animations, so I guess we can do that now. So I'm going to right click in our content folder and blueprints and create a new structure. We're going to call this s underscore turn animations. So turn anims. Let's open it up, and we're going to need 4 variables of type anim sequence. First one is going to be turn left 90, turn right 90, turn 180 left, and turn 180 right. Let's close. And we can also close the animation. Now let's create a function. This function is going to be called select turn in place animations. So let's do select turn in place anims. So let's get our root year offset. Now remember, the only variable that we have not set yet is the actor root year offset, the actor year offset variable. Right, so just be mindful of that. I'm just going to drag this variable here to keep things tidy. And let's get from the root year offset, let's minus 180. And let's normalize the axis. Now, as you can see here, the normalized axis node says it clamps an angle to the range of negative 180 to 180. So I guess you can see why I'm doing that there. Now let's get the absolute value of this. And let's check if it is less than 50. If it is, let's proceed off with the true. So if it's less than 50, in the tutorial, what I had was, and I'm just going to create a real quick demonstration, but I will not be covering the crouching turn in place animations here. Although, as long as you follow this tutorial, you'll see exactly where to place them. So I'm going to add a return node, and I'm going to return type anim sequence. And let's just call this return value. Now this function is a pure function, so ensure to check pure. Off of the return value, let's run a select. And again, in the tutorial, I had a boolean here that was selecting if we are crouching or not. So I'm just going to replicate it just for the persons that already, got somewhere with the course. Next, I want to run another select. And we're going to connect this to the false and duplicate it and connect it to the true. So the condition will be a variable. Let's call this should turn CCW for counterclockwise. And let's leave this right here. Great. Now that we have this, we can insert our variables. So here is where we do our turn in place 180 animations. Right, and off of the false, we're going to duplicate this, duplicate the return node, and here's where we do our turn in place 90 animations. The conditions will be the same. Now what we're going to do here is create a variable of type structure that we just created with animations. So let's get turn in place anims, and we're going to look for our structure s turn anims. Compile. We're going to drag this in. I want to split the structure, and I guess we can just break it. So I'm going to break just to keep things clean. And let's call this the standing ones. Standing turn in place anims, and this one will be the crouching. Turn in place anims. So for the standing turn in place anims, let's do turn right 180. We'll go to the false. And turn left 180 will go to the true. You can reposition this in the structure if you want to keep it a bit more clean. I'm going to hide any unconnected pins, and I want to duplicate this. I'm going to replace the variable with the crouching variable, and we're going to do the same thing. So right to false and left to true. That's it. Now let's duplicate this, I guess. We're going to hide both animations for the 180 and select both for the 90. Now we're going to do really similar things. So turn right 90 to the false and turn left 90 to the true. We're going to do the same thing here. Again, you can reposition this however you feel in your structure, so it could be a bit more neat and the lines would be a bit more straight. Now that we have this function, let's see, we need a function called process turn your curve. So what we're doing right now is we're setting up all the functions and variables and data, and then we'll head across to the anim graph and create all the states and set everything up, and I'll show you how to add all the transitions and what settings to use and all that good stuff. So in here we need a variable, a new variable. We're going to call this turn your curve value. It's going to be of type float. Bring this into our graph, and let's duplicate it actually. And this is going to be our last turn your curve value. Let's set it, and let's connect this here. Next, let's look for a node called get curve value, and the curve name we're looking for is our turn your weight curve. So remember, we created a variable for the name. We have that now. Let's drag it in, connect it up, and we're going to check to see if it is less than 1. If it is, right, so if it is, then we want to set the turn your curve value to 0, and we also want to set the last turn your curve value to be 0. But if it's not, let's add a branch. We need a bit of room here. So what we're going to do is check if our let's duplicate this, our curve value for the remaining turn your, right? We're checking if we're checking if this first one is less than 1, and we want to save divide between both of them. So let's divide, let's do safe divide, and connect this to B. I'm just going to create a few reroute pins here. Now we have the turn your weight. Oh, I'm seeing an error here. Alright. Save the by boats, and then we'll want to set our variable for the turn your weight. So that's how we get this data, and it will now populate the last turn your curve variable data as well. So we'll have both. Now we're going to check if our last turn your curve data is not equal to 0. And if it's not, we can proceed. Alright, so we're going to check if it's not equal to 0. Let's get our turn your curve value, and let's minus the last turn your curve value. Now we want to get our root year offset, and we want to minus the return data or values from this previous calculation. And we want to call our previously created function set root year offset. Connect it to the true, and connect this to the input of our set root year offset function. Great. So let's see. Let's close this off. Save. What we can do here is simply check if the owner is valid. Again, in the YouTube tutorial, I did a more thread safe operation. I ran it here, but since this is just for the turn in place only, I'm just going to call it right here. So the function I'm going to call is the update root year offset data, and it will require an input of type delta time, and this will be our delta time x. So let's straighten this. Great. Now, let's dive a bit deeper. So now let's head to the atom graph. Now we already created this. So what we need is to, let me think. Let's create a state machine. Let us call this main state. Connect it to the initialization node and open it up. Now in the tutorial, again, I had an idle state, and inside of this idle state is where I created another state called the turn in place state. So it contained the idle and the turn in place data. Now in the idle here, in this state, idle state, we're going to select the output, and we want to bind a function to the on update, and let's rename this function to be update idle state. Okay, let's see. It's really simple actually. So we just need to get our root bone mode, connect this here, set it to be accumulate, and then we want to call our process turn yield curve function that we created previously. Connect this to the return node, and that will be it. That will be it for this function. The next function, let's see. Let's compile, and let's open up. So select the process turn yield curve function, head to the details panel, and under advanced, let's ensure that it is set to thread safe. Compile. You won't have this issue anymore. You can see we have some others, which is the set root year offset. Select this, ensure that it is thread safe, compile, and you don't have that issue anymore. Great. Let's head back to our idle state here. Open up our idle turn in place graph or state, and let's create a new entry, a new state. And this will be our idle. In here, all we want to do is insert our idle animation. So let's look for idle. Connect this here. Highlight it and make sure loop animation is set to true, because you want your idle animation to be looping. Now let's do a bit of testing. So let's open up our third person folder, blueprints, third person character. And right now, if I hit play, the character will be in its base default state. You can run around, and as you can see, orient rotation to movement is set to true. But that's not what we want. We want to be able to turn, and this is initially supposed to be a strafing system. So let's select our character movement component, scroll down, and let's ensure to uncheck orient rotation to movement and select use control desired rotation. Compile and save. Now what will happen? You can see the characters, spinning like crazy. Alright, so the rotation isn't controlled. Now that is fixed with the update idle state function. And the reason why it's not working right now is because in our process turn your curve function, we're getting the data and we're setting the root year offset. We're getting all of this and we're running all of that. But in the update root year offset data function, remember we created a variable called actor year offset that we did not set up yet. So let's set this up right now. Right, so let's set up our actor year offset variable. Let's rename this to be actor year delta. Right, so we're gonna need two variables of type float. I'm gonna call this the actor year, which is the current value, and I'm gonna create another one called the last actor year. Right, so it's the previous value. We're gonna let's do it right here, I guess, right before we update our update root year offset data function. So what I'm going to do is get the actor year, and I'm going to set my last actor year off of the isValid pin, and we're going to set the last actor year to our current actor year value. Next, we want to set our current actor year based on our current axis rotation. So let's get a property axis node. I'm going to bind to try get pawn owner axis rotation, and the only one we need is the yaw. Alright, so it's the rotation. And next we want to compare both of them. So I will get my current actor yaw. I want to minus my last actor yaw. And that's how we set our actor yaw delta variable. Let's compile this. Now we can just collapse this into a little function. Set up actor yaw delta. Let's bring this back in. Great. So I'm going to select my mesh. I'm going to scroll up here and select ABP turn in place. So now you can see using the animation that we inserted for idle, and he can't turn anymore even though use controller desired rotation is set to true. Now you might think we wasn't really effectively checking that, so I'll show you now. So now we have the animation blueprint slotted. Next, let's head to our anim graph, main state, idle state, and let's just remove this function. Let's reset it, and now you can see that the character will be rotating, all crazy. So now what we need to do is bind the function to the on update. So let's rebind this. So now you can see that we don't have that issue anymore. We can move around and whatever. Good. So let's proceed. So in our idle turn in place state, we want to drag off of our idle, and we're going to create a new state. This state is going to be called turn in place entry. So this is our entry state, and the condition is really going to be really simple. So let's get our root year offset variable, and we're going to check if the absolute value of this is greater than 50. All right. So if it is greater than 50, then the condition can, the transition can be entered, which is the turn in place entry state. What we're going to do is promote this to be a shared transition rule, and let's just call this turn in place. That's fine. We don't need anything here. Duration can be 0.2. Blend logic is standard blend. That's fine. So let's create another state from the turn in place entry state, and let's call this the turn in place recovery state. So let's call it turn recovery. So, and let's create a transition going back up to the turn in place entry state. So essentially it's going to be bouncing between both of these states as long as input, mouse input is received. So let's select this transition going back up to the turn in place entry, and we're going to use our shared turn in place transition rule. For this one, there's a slight change, which will be the blend logic. For this one will be an inertialization blend. Now remember, we added the inertialization node here, so without this would not work properly. Next, from the turn in place entry to the turn recovery transition, let's open this up. And it's a really simple condition as well. So we're going to get the, where is it? Turn your weight variable that we have. And let's get the curve value from that. And we're going to check to see if the curve value is nearly equal to 0. You can leave everything else as is, which is the tolerance. That's fine. We're going to select this and ensure that the duration is set to be 0. This is also a standard blend. Nothing else needs to be changed here. I'm going to bring this in, and I'm going to connect my turn recovery to my idle state, and this is simply automatically returned. So let's use an automatic rule based on sequence play A in state. So essentially what's going to happen here is when we're idle and we apply your input, it will then head to the turn in place entry state. Then it will come down and check to see if the this state is active. So it will go get the animation, play it, and return. But if it plays the animation and it receives input again, it will go back up, get the new animation, and come back down and play it again. So these transitions need to be really well put together. So let's do the turn recovery since it's the easiest. It's simply get a sequence player, connect this to the result, and now all we need is to bind this sequence to a variable that we haven't created yet. So let's create one now, and we're going to call this a final turn animation. And this is going to be of type anim sequence. So let's select our sequence player again, and let's bind the sequence to our variable. Next, for our start position, we need a variable as well. Let's call this turn in place anim time. So we want to bind our start position to our turn in place anim time variable that needs to be a float. Great. Now let's ensure that should loop or loop animation is set to false, because we don't want this animation down here to be looping. We want it to play once and either return to idle or check again to see what animation is desired. Now in our turn in place entry state, this one is going to be a slightly longer, but you'll be fine. So let's select the output animation pose, and let's bind the function to the onBecomeRelevant. And we're going to call this setup turn in place entry state. So it's going to be really easy. So let's get the root your offset again, and let's get the sign. All right, so we're going to check to see if this return value is greater than 0. And if it is, then we want to set our should turn CCW variable, which is our counterclockwise variable, and return. Let's close this. Head back to our turn in place entry state. And we want to get a sequence evaluator. So we need a few things. So let's connect this to the result. Let's uncheck should loop. And let's make the explicit time a dynamic value and the sequence also a dynamic value. So let's create some functions. So we're going to bind a function to the onBecomeRelevant. I'm going to call this setup turn in place items. So what I'm going to do here is let's convert this to be a sequence evaluator. Next, we want to set a sequence with inertial blending. From the, let me think. Let's connect the context and let's set our final turn animation variable. So connect this here, and the output of this variable will go into the sequence. And just create some reroute pins to keep things clean. Instead of dragging this pin, let's get the context input. And for the final turn animation input, we created a function called select turn in place items. I made a little error here. Select turn in place items and connect this here. So this function will select everything for us. Again, ensure that it is thread safe. Moving on, what we need is to, from the sequence evaluator conversion, we can set the explicit time to be 0. And we want to set our turn in place anim time to be 0. We're going to close this off, head back here, and we want to create one more binding on the update. So I'm going to call this update turn in place anims. Great. So from the context, let's get the delta time. And from the node, we can convert to sequence evaluator again. So we're going to get delta time plus the turn in place anim time. And we're going to set the turn in place anim time. So that's how we're going to populate this variable with data. Next, from the sequence evaluator here, we can drag this here. Let's get the node input. And we're going to set the explicit time to be our turn in place anim time. Next, we return, compile, and that is it for our turn in place system. So I'm just going to walk through again. Now, if you try to play or try to turn your mouse or whatever, he will enter the A pose, as you can see. So what we need to do is populate our two variables that we created for our structure. So seeing as I only basically set up the standing, although I showed you how to set it for crouching as well, I did not set this crouching variable. So you can, it's really easy, but I'm not going to do it in this video. So for the standing, I'm going to hit the little drop down here, and I'm simply going to look for our turn animations. So I'm going to insert my turn left 90, my turn right 90, turn left 180, and turn right 180. Compile. Now let's turn. You can see we have this little issue. And a lot of people had this issue, and it's a really easy fix. So as you can see, it's simply not processing the curves properly. And we have a function that processes the curve, which is process turn curve. And we can see that we're checking to see if the turn yaw weight is less than 1. And if it is true, then we set it to 0. But if it's false, then we do a division. And we're dividing between the turn yaw weight and the remaining turn yaw. But what we need to do is swap these values. So this would be A, and this would be B. If I compile and I play now, you can see it processes the curve properly. So that's how you fix that issue. And 180 works as well. Great. That's it, guys. See you in the next one.